All right, Freda Heights. Good old Freda Heights, right? She throws this ball from the roof of this building, right? So here's the ground. Here's the windows in the building, right? It's like for Harold and the Purple Crayon. Is that his name? Okay, so there she is, just throwing that ball. Throwing the ball. Okay, so it from a height of 21.7 meters. So this, let's say she throws the ball. It goes up. And it goes down. Okay, but this elevation right here, this is our 21.7 meters. Okay, I think a picture helps. These are tricky problems. Okay, and it hits the ground 3.78 seconds later. Okay, what is the initial velocity of the ball? There we go. With what velocity does the ball hit the ground? And I think we can answer those questions with one suvat. So let's do that. Okay, so let's go from Freda to the ground. Now, a lot of people think that you have to solve this by somehow figuring out the top and then from the top down, but you don't. Let me show you. Let's go suvat, S-U-V-A-T. Okay, so our displacement is we started here and we end there. So our displacement is that we actually go down 21.7. Okay, it's negative because we started here and we went there. It's not more than 21.7 because remember, displacement is not distance. The total distance traveled would be hard to figure out. We can do it. We could do it easily, right? But remember, displacement is the net change in position from beginning to end. Okay? So in these problems where it goes up and down in the same elevation, the displacement's actually zero. We didn't solve them that way, but it is zero. You can try it. All right, so negative 21.7. So it started here, it ends up down there. We end up 21.7 meters lower. Our acceleration is negative 9.81. Right, our initial velocity we don't know. Our final we don't know. But we do know it's 3.78 seconds. Right? And it almost seems like this is unsolvable because we don't know either one of those velocities. But it turns out that we have this formula, right? We will use, I guess, no v to find u. It seems like magic, but it's just good algebra, kids. Right, so this guy, this is no v, right? We know everything here but u, so let's plug this in. Minus 21.7 equals u. It's u, 3.78. All right, plus 1/2 negative 9.81 times 3.78 squared. All right. How do we solve this? Well, ultimately what we're going to do is we're going to go this minus this, and then that whole thing divided by this. So let me just show you. We're going to go parentheses. Minus 21.7 minus 1/2 negative 9.81 times 3.78. That whole thing, right? That equals u times 3.78. So if I divide this by 3.78, that's going to equal u. You could just do math however you want, but this is what I'm doing. All right, here we go. So left parenthesis, negative 21.7 minus 0.5 times negative 9.81 times 3.78 squared. Is that indeed what I typed in? Looks like it. Okay, right parenthesis. I'm ending my numerator divided by 3.78. Holy cow, 12.8000, right? $8,001. Oh, sorry, that's a 1. 5 something anyway. So 12.8, positive 12.8 is our initial velocity, right? There's a couple zeros after that, right? So that's pretty good, right? With what velocity does it hit the ground? That's our answer there. Right? I'm just going to use v equals u plus at for that, and v is u plus at. Okay, so final velocity. Okay, v is equal to positive 12.800. The next two digits are 0. Uh-oh, my pen's getting slow. Okay, plus negative 9.81. Got to write slowly. Ooh. Okay, times t. No, t is 3.78. 3.78. There we go. All right. Oh, we can just do this, can't we? Okay. So that number, I'm going to store that number in my variable u, the 12.8, whatever, and then I just go plus negative 9.81 times 3.78. All right, if you wanted to get sassy and just say minus that, right? I'm getting negative 24.28. So the final velocity is negative 24.28 meters per second. So there, it hits the ground with that velocity, right? So it leaves here with positive 12.8. Right, hits the ground going negative 24.3. Okay, this is asymmetrical, and that's because, of course, the downward trip is longer, and so it hits the ground going faster than it left the hand going upward, right? To be sure, when it reaches this elevation right there, it's going negative 12.8 right at that moment. Okay, so we've done initial velocity of the ball, right? We've done the with what speed does it hit the ground, right? How high above the building? We'll do that in the next video. And then we'll do the 2.12 seconds after the ball was released.